Hello. So in this video, I wanted to go over our logic unit section and what you should expect for our first quiz on Friday. On Friday, what will happen is that you'll be able to download our quiz at on Friday morning at 8 a.m. And you'll have up until 24 hours up until Saturday at 8 a.m. to download the quiz, type up your solutions, and submit it back on Canvas. You'll have 24 hours to do it. It's open book and open notes, so you're free to go back on look at the worksheets that you've done, look at previous lecture videos if you think it'll be helpful. But I don't want you to consult other people, like other classmates or any other people. Please work on the problem on your own. And I would also prefer if you didn't Google or try to answer something. So just open book and open notes, but please work on it on your own. I am giving you 24 hours, but I don't expect this to take anywhere near as long. I think most students would be done in half an hour with time to spare. So expect it to take about half an hour and maybe like 10-15 minutes for downloading and typing things up and uploading, all that logistic stuff. So if you have about 45 minutes, you should be able to do it. If you have any questions, you can email me, and you could also reach me on Discord channel. And I'll try to get back to you as soon as possible. So I hope I'll be able to clear everything up, but I'm a reasonable person. So if there's some internet connectivity problems or something that comes up, don't hesitate to try to contact me. Okay, with that said, let's jump into just kind of brief review of what we've done in the past couple weeks. Okay. All right, so we have been going over logical paradoxes. So we've done Liar's paradox, which is like sentence that says something like, this sentence is a lie. And the way we resolved it was that this liar's sentence, like this sentence is a lie, is not a statement. And what I mean by that is that it's not a sentence that we could categorize as either true or false. So it doesn't count as a logical statement. That's how we resolve that one. A Grayling-Nelson paradox, this is with the categorization of the word, is it autological or heterological? And one way to resolve this paradox is to say that words can be neither of those two things. It's neither autological or heterological. Barbarous paradox is where you have a barber, male barber who shaves every man who do not shave themselves. And basically, this is the way to resolve it is kind of, it's inconsistent premise. It's impossible to have this barber because you can't decide if the barber shaves himself or not. And Russell's paradox is the mathematical version of this one. The resolution is a little bit complex, so I am not gonna test you on the Russell's paradox itself. So I'll just say don't worry about this particular paradox for this quiz. Okay, but I've listed a few of these paradoxes that we've covered, and I hope you kind of see this. There's a theme inside of it, so there's a lot of commonality, and that's that they're kind of self-referential. Each of these paradoxes kind of refers to itself. So those aren't all the logical paradoxes out there, but a lot of the paradoxes that we covered so far has this theme. So that's one thing to look out for possible sources of paradoxes. You should know the historical importance of these types of paradoxes, especially the Barbarous paradox and the Russell's paradox on mathematics. So because mathematicians wanted to solve this Russell's paradox, they've got more robust, carefully thought out set theory. And set theory is like the foundation of mathematics. Everything in mathematics kind of depends on sets. And we have a better set theory that avoided this paradox. Another thing that came out of it is that the Gödel's incompleteness theorem. So this is a theorem that pretty much says that math cannot prove everything that's true. So there are limitations in mathematics. So what are some of the basics you should know and be able to do for this upcoming quiz? We're not going to ask you to do too much like logical proofs. That's not the point of the logic section here. That would take a whole quarter to talk about proofs using logic. But I want you to be able to translate between natural language and then being able to identify what kind of structure their arguments have, and kind of translate back and forth between natural language in English versus symbolic language. For example, like, oh, they're using the and connective to structure this sentence or their claim. So you should be able to go back and forth from natural language and symbolic language. So maybe I could give you symbols and you translate for me what that means, or if I give you a sentence, translate that into symbolic language. And in particular, you should be able to deal with these 5 connectives that we've covered. This is the not connective. This is the and, or this is if then or implies, or implication. And then this is the biconditional, or if and only if. So these are the types of connectives that you should know how they work in terms of how the truth comes out to be, truth value. It's if you combined true statement implies a false statement, is that after combining, do you get a true statement or not? These things you should be able to do. If not, if you're not sure, then you should go back to the videos on basic logic, and I think there's 2 videos on connectives with the implications as well. You should be able to provide counter example to statements. So if there's an if-then statement, you should be able to come up with an example to kind of what consists as a counter example to disprove a statement. Similarly, you should be able to disprove universal statements. So if there's a type of statements, all apples are red, then to disprove it, all you need is an apple that's not red, right? So there's some green apples. So you can disprove that statement by using that kind of example. If somebody says, all apples are red, and then if you just say, well, I have a yellow banana, that does not disprove the statement, right? So be able to identify something that disproves statements. On the other hand, if you have an existential statement like some apples are red, you can't disprove that by giving an example. So green apple in this case does not disprove an existential, like some apples are red. Well, some could be other colors as well. So know the difference between those two quantifiers and how to refute them. Okay. We've done a lot of puzzles in this section. So be sure to be able to solve the two-door riddle, Knights and Knaves puzzle, green-eyed riddle, robot repair puzzle, all of those things, and maybe a slight variation on those things. So go back and see if you can, if you feel comfortable with all those types of puzzles, and see if you understand the solution enough to explain it. I haven't made any videos on them, but it's part of your homework to learn about logical fallacies. So after the homework set 2 is due, you've done 4 logical fallacies. So if I give you a new, like a fallacious argument, you should be able to point out what part of their argument was bad, and be able to point out the fallacies by the names that you learned from the book. So expect a question on that, and make sure you feel comfortable enough to do it. And you don't have to memorize it, right? Because this is an open book. So as long as you understand the concepts, you can look it up and, oh yeah, this is a straw man type of argument, and be able to point out why those arguments are fallacious. Okay, so that's pretty much what you need to prepare for the quiz for Friday. I'll see you in a different video starting our new unit on probability theory.